today's lesson is 3.3 about nutrition using proportions and percent equations. And your learning goals are to solve proportions, and you're going to solve these percent equations. Okay, so your key term is percent equation. We're going to now learn that today. So read through with me. Which food is the healthiest in the world? Of course, fruits and vegetables are the healthiest. But which fruit or vegetable is the healthiest of them all? That's hard to say because it depends on which vitamins and minerals are being compared. However, in 1992, the Center for Science in the Public Interest tried to answer this question. They compared different fruits and vegetables looking at the amounts of fiber, iron, calcium, protein, and vitamins A and C each offers. After completing their research, the center determined that the healthiest vegetable was none other than the sweet potato. Are you surprised at this conclusion? Fruits and vegetables are important for a balanced diet. But what does it mean for a diet to be balanced? What things in mathematics are balanced or not balanced? So hopefully if you're thinking about some things in mathematics to be balanced, you might think back to our algebra unit. What kind of things did we balance there? Hopefully you're thinking about equations. Well, we're going to get into that today, but now with just percents. Okay, problem 1, calorie counts. The average calorie requirement for an adult is about 2,000 calories per day. The recommended distribution of calories is 57% from carbohydrates, 30% from fats, and 13% from protein. You can use a proportion to determine the number of calories that should be from carbohydrates. So we're going to start with carbohydrates and work from there. Okay, a proportion can be used to solve a percent problem and is written percent equals part divided by whole. Step 1, you're going to set up a proportion. Let C represent the number of calories for carbohydrates. So we know it's 57%, so it's 57 over 100. And then we said the whole total calories is 2,000, so that's on the bottom. And then the part we're going to represent as C, the number of calories of that 2,000 that should be carbohydrates. Step 2, rewrite the proportion to isolate the variable. So you're going to do your cross multiplying, and you multiply your 57 times 2,000, and then your 100 times your C, and then you isolate that variable by dividing by 100. So step 3, perform the multiplication and division to determine the value of C. So once you have set up your proportion, so you have your percent, 57% over your whole, 57 over 100, and equal to the part C over your total 2,000, you can rewrite the proportion to isolate that variable, do your multiplication, and you would get your multiplication and your division, and you would get calories that should be carbohydrates would be 1,140. So for an adult, the recommended number of calories per day for carbohydrates is 1,140. So what do you know in number 1 here? Use what you know about solving proportions to explain how the variable is isolated. So looking back over to step 2, think back to our algebra unit. How do we isolate C? Remember, we always think about opposite operations. Right now, that's C times 100. So in order to isolate C, we divided both sides by 100. So I'm going to write number 1 up here because I don't have a great handwriting down there. So we would divide both sides. Ooh, this is not looking good. Okay, so that looks a little better at least. Divide both sides by 100. That's what we would do to isolate that variable. Okay, you can also use a percent equation to determine the number of calories that should be from carbohydrates. So you can also use this percent equation instead of just a proportion. A percent equation can be written in the form of percent equals whole equals part. Percent times whole equals part, where the percent is often written as a decimal. Okay, so look in the box. Percent as a decimal times the whole gives you your part. So your percent of carbohydrates, we know, was 57%. So it's 57 over 100, which we can write as 0.57 because you move the decimal 2 places over. 57 over 100 would be 57 hundredths, times your whole, which we know is 2,000 calories, would give you your number of carbohydrates. And if you multiply 0.57, 57 hundredths, times 2,000, you again get your calories for carbohydrates of 1,140. So again, on this question, it says explain how the variable is isolated. Then describe how the number of calories from the carbohydrates is calculated using the percent equation. Well, I guess it's kind of a trick question. Did we really have to isolate the variable? No, we really didn't. And in the next part, it just says, well, then describe how the number of calories from carbohydrates is calculated. So what are you really doing? You're calculating the carbohydrates by multiplying 57 over 100 or 0.57 by 2,000. That's simply all you're doing. Okay, so let's move on to the next one. Okay, so now use proportions. So we're going to use proportions and percent equations to calculate the number of calories from the fat and protein. So we're going to look at fat and protein that are recommended for an adult on the 2,000 calorie diet. So we're still staying with the 2,000 calories. Okay. For each, isolate the variable first, then determine the number of calories from fat or protein recommended. Finally, write your answer in the complete sentence down at the bottom. Okay, so let's think about our proportion. What's it going to look like? Well, the fat, first we're going to look at fat. We know we have 30%. So if we use a proportion, we write 30% as 30 over 100. Okay, and we got to name our variable. We'll just say F is fat. And we want to know how much fat over the total calories. So fat over the total 2,000 calories. Okay. And you need to go through and do your cross multiplication and divide. Set that up. I'll let you solve that and see what you come up with. And then let's look over at the percent equation. Well, again, you can do it one of two ways. You could have the 30 over 100 for your percent. 30 over 100. I wrote that wrong. Just give me a second. Okay, so you can multiply the 30 over 100 times the 2,000 to get your fat. Or you can do the 0.3 times the 2,000 to get your fat. And they all come out to the same thing, that F equals 600. If you multiply 2,000 by 0.3, you should get F equals 600. And again, I didn't show you the cross multiplying and dividing because that is previous lessons. Hopefully you remember that from previous lessons. Okay, and then your sentence, I'll let you write what you think your sentence can be right here. Probably something like the recommended number of calories from fat is 600 calories, or a person should eat 600 calories per day of fats. All right, so I want you to do the protein now on your own, and then pause the video, and then come back when you feel like you have gotten it. Okay, again on this one, you should have come out to after you do your proportion of P equals 260, or you can do your percent equation 0.13 and times 2,000, you still come out to 260. So you can come up with your own sentence. Again, I didn't write it, but it would be something like the recommended number of calories for protein is 260 calories, or a person should eat about 260 protein calories on a 2,000 calorie diet, something like that. Okay, so now we're going to kind of sum up problem one here with a few summary questions. Describe how the strategies you use to solve the proportions and the percent equations are similar. So if you look at both proportions, if you kind of go back and look at proportions, you multiply the total number of calories per day by the percent from either fats or proteins. So look at that. Okay, so if you look at these equations, you can see in the proportion equations, when you're solving the proportion, you're multiplying by 2,000. And if you look at the percent equations, you're also multiplying by 2,000. So the strategies are similar there. So let's go back and write that down. So write down that similar strategy. Okay, so you multiplied the total amount by the percentages in each one. Okay, or here, okay, or you can also think of it as in decimal. So you're doing that in each one. So I multiply, number 4, I would write something like, I multiply the total number of calories by the percentages for each, was it protein and fat, maybe. Okay, let's look at number 5. It says, describe how the percent equation in the form of percent times whole equals part is equivalent to a proportion in the form of percent equals part times whole. So if you look at when you multiply both sides of the proportion by that 2,000 whole, you actually get the percent equation. So let's go back and look at that. Okay, so now look at these proportions again. If you did multiply both sides by 2,000, these 2,000s would cancel out. And if you would actually have your percent equation with the fraction form. If you look, it's 30 over 100 times 2,000. They actually are equivalent. They're the same thing. And if you look over here, again at the bottom with the protein, these 2,000s cancel out. You're left with P. So you'd have 2,000 times 13 divided by 100, or 2,000 times 13 over 100 equals your P, which is the same thing as your percent equation over here. So if you multiplied both sides by 2,000, you'd actually end up with the same thing. All right, now let's look at number 6. Oh, so we should probably put a sentence together for number 5. Think about a sentence that would explain how those are equivalent, those two types of equations, and then come back here when you're done. Okay, so you should write something like this. When I multiply both sides of the proportion by 2,000 slash the whole, I get the percent equation. That happens every time. Okay, so number 6 says, describe the strategy you can use to rewrite the percent equation as an equivalent proportion. So now we're going to go backwards. Basically, we're trying to see that these are both the same thing. So if you multiplied to get by the whole to get from the proportion to the percent equation, what do you think you're going to do to go backwards? Well, hopefully you're thinking I should divide by the whole. So let's go back and look. All right, so let's look at these percent equations. So I'm using just the fraction just because it looks, I don't know, you can use either one, the decimal or the fraction. I'm just choosing to use a fraction. So if we divided both sides by, if we divided both sides by the whole, so that's 2,000. What you do to one side of the equation, well, you got to do to the other. Well, what ends up happening? Well, 2,000 divided by 2,000 is that, and you're left with 30 over 100 equals F over 2,000. Okay, and if you look, that actually matches back to our proportion. Okay, let's do the same thing for the protein. Divide by the whole, which is the whole 2,000 calories on both sides. Okay, those cancel out. The 2,000 divided by 2,000, you're left with 13 over 100 equals P over 2,000. And if you look at that, that matches our percent equation, or our proportion over here. So they both match back to the proportion. So now let's come up with a sentence. So that should be kind of the opposite as number 5. Try it and then come back here and see if you get the same thing I did. Okay, so hopefully you got something kind of like this. I can divide both sides of the equation by the whole. So this time now you're dividing. So basically what you're trying to prove there is that no matter which equation you use, the proportion or the percent, they actually end up being the same thing. It's just whichever one you're more comfortable with. Let's move on to problem 2. Okay, a person on a 2,000 calorie per day diet consumes 800 calories of fat. What percent of this diet comes from fat? Can you use a proportion or percent equation to determine the percent? So hopefully you realize now we're going to kind of work backwards. Instead of finding percent of a number, we're trying to actually find what percentage this is. Okay, so look in the box. If you use a proportion, I'm going to start on the left side here. You're going to say, okay, well, now I know my totals. So the right side of my equation, I've got the 2,000 calories, and now I know that I have a total of 800 for, I believe it's the fat. Okay, but I want to know percent out of 100. So that's why now I have F over 100. So you just do your cross multiplying and dividing. So once you do that and do your multiplying and dividing, you should come out to 40. Okay, now look at the percent equation. Okay, here you're multiplying by the, you're doing a little different because there is going to be some solving here. Okay, now you know the part, so you know that equals 800. Okay, but you're trying to figure out what percent you're multiplying by, F, times that total. Okay, so you do 2,000 times F and equals 800. Isolate your variable by dividing each side by 2,000. Okay, and then you get F is 800 over 2,000, which is 0.4, and we know that 0.4 is really 40% if you turn it back into percents. Whereas when you look at the proportion solution, it's already in percent form because it's using the fraction form. So there's a little different there. Even though they mean the same thing, they both mean 40%, even though one's represented as a whole number because it's already using the fraction form per percent. But if you're using the decimal form, you have to convert it back to percents. Okay, so fat makes up 40% of the person's 2,000 calorie per day diet. How was the variable isolated in step 2 when the problem was solved using proportion? And then number 2, how was the variable isolated in step 2 when the problem was solved using a percent equation? Well, I just talked you through that, so you should be able to come up with some sentence that makes sense. So I want you to try to talk about how you isolated the variable using your proportion and then also the percent equation, and come back here when you're done. Okay, so hopefully you recognize that on the proportion, if you did your cross multiplying, you would get 2,000 F equals 800, and you would actually have to divide both sides by 2,000 to get F by itself. That's what you get over here. And if you look over, it's easier to see over in step 2 for the percent equation, you can see that you would get F times 2,000 equals 800, and that you would need to divide by 2,000 on both sides to get F by itself. So you actually, in this instance, since you're kind of working backwards, you do the same thing. You divide both sides of the equation by 2,000, but the first one you would actually do some cross multiplying. So number 3, how can you make the conclusion that 40% of the person's diet is from fat when the result from using the proportion is F equals 50, and the result using the percent equation is F equals 0.4? I already mentioned this before when I was explaining. So think about the fraction form versus the decimals used, and write a sentence here as your explanation, and we'll talk about it. All right, I'm not going to write this one, but you should have written something like, in the proportion, your F for fat is 40%, so it's already written over 100, which means 40%. But in the percent equation, where F equals 0.4, you're using decimals for an equivalent to 40%. So since you're using a fraction versus decimals, it makes it different. Okay, let's look at question 4. A person on a 2,000 calorie diet consumes 1,000 calories of carbohydrates and 200 calories of protein. What percent of the person's diet comes from carbohydrates? What percent comes from protein? Answer these questions by using proportions and percent equations in the table shown. For each problem, isolate the variable first and calculate the answer. Finally, write your answer in a complete sentence. Okay, so I'm going to have you do these on your own. Remember to kind of use your proportion, put in your variable where it belongs, and in your percent equation. Okay, remember this time you're looking for the percent of carbohydrates and proteins. Do that now and then come back and check yourself in the video. All right, so you should have gotten F equals 50% or F equals 0.5, which would still be 50%. So carbohydrates for your sentence, it would be like something like carbohydrates make up 50% of the diet. And for protein, you should have gotten 10%. And if you use the proportion, it'll be straight up 10, meaning percent, because you're using a fraction, or 0.1 or 0.10 or 0.1, use if you did the percent equation. And so then protein would make up 10% of the person's diet. Number 5, I'm going to let you answer that on your own. You just need to explain how you solved each proportion and how you solved each equation. Okay, number 6, determine each person's total caloric intake for the day given the percent of the calories consumed. Show your work and then write a sentence to explain your answer. So on Monday, 50% of the calories Johnny consumed were carbohydrates, which totaled 1,425. What was his total caloric intake? So here's a little different. They don't tell us the total caloric intake. We actually have to figure that out. Okay? So we can call that whatever we want. Maybe you use, let's not use C since we use carbohydrates. We'll just use N. It doesn't really matter what you use. And see if you can come up with the proportion first. But we know that it's 57 over 100 because it's 57% carbohydrates. And we know that that is 1,425. And so we're looking for this total calories here. Okay, go ahead, since I kind of helped you there, I want you to finish this up and then do the same one for fat. Okay, even though I'm not showing all my work here, you really should. This is just so you can check yourself. But you should have set up the proportion for carbohydrates, 57 over 100 equals the 1,425 total carbohydrate calories over N, which is our total. If you cross multiply and divide, you get your total calories for the day would be 2,500. Or if you use the percent equation, you can use the decimal, 0.57 N equals your total carbohydrates, 1,425. All right, so N, your total amount, would equal 2,500 if you divided both sides by 0.57. And then down below, you can check yourself on fat. You do the same thing, except it's 30%, so it's 30 over 100. And then total fat calories is 540 over your total N calories, and you should get 1,800. And if you, for your percent equation, instead of using 30 over 100, you could just use 0.3 times your total calories. 30% of those total calories should give you that 540. So if you divide both sides by 0.3, you would have gotten that same 1,800. Okay, look at C. On Wednesday, 13% of the calories Cheyenne consumed were protein, which totaled 330 calories. What are her caloric intake? Same as A and B. You just need to finish it off for C. Okay, so again, these look like your equations. Hopefully you got these equations. I went ahead and solved it for one of them so that you could see the answer. Okay, last 2 questions. Crystal says that when she solved the proportion in question 6, she could set up her proportion any way she wanted because ratios can be written in any way. So do you agree with Crystal's statement? Stop and answer that question. And then I want you in number 8 to go ahead and do that. Describe how you solved each proportion and percent equation in number 6, in question 6. And then come back to the video when you have thought about it. I'm not going to write down this answer, but hopefully you realize that no, you cannot write proportions any way you want, like Crystal says, okay? You should have written something like, the ratios can be written in different ways, but you have to be careful because if you set up the proportion incorrectly, they would not be the same, okay? You have to make sure that when you set up the proportion, you're matching up in your numerators, your parts, and then in your denominators, you'd have to match up your wholes. Otherwise, your percent equation and your proportion wouldn't be the same. They would mess up. And then number 8, you can answer that however you want. You just describe how you actually solve these proportions and percent equations so you can solidify that in your head. Now you're ready to go practice.